I'm here to talk to you about the infrastructure that's powering Rust and the Rust project. Rust is an incredible language. I love it to death. And it's been extremely satisfying to watch the growth of its popularity and its community. But kind of looking at the infrastructure behind the project, this growth comes with challenges that we need to address if we want Rust to be kind of a foundational piece of technology for the next decades. And this is what I'm here to talk to you about. Before jumping into the actual talk, I want to quickly kind of introduce myself. My name is Jan David, but generally everyone just calls me JD. And I joined the project's infrastructure team pretty much a year ago when the team asked the Rust Foundation for help and asked to hire someone to help out full-time in the team. And for the past year, that has been my job. I've been working full-time on the project's infrastructure with a focus on our cloud components. And I want to start this talk with like two kind of quick questions to make sure we're all on the same page. And the first question is like, what is our infrastructure? And then the second is, why should you care about it? And on a very, very high level, I would introduce our infrastructure as like a set of tools and services that we operate to help people develop and use the language. I don't want to go into like too much detail and give you just a rough idea of what I'm talking about by looking at a few things that the infrastructure team is managing. And I can promise that like everyone here has probably used at least one of them. Generally speaking, we can group our infrastructure into kind of these two different sets of tools. We have infrastructure that mainly supports the development of Rust, and we have infrastructure that mainly supports the use of Rust. And I'm not going to go to too much, but I want to highlight like a few important examples for each. On the contributor side, we have tools that support the development of the language. And most importantly, and we'll touch on this a little bit later, we have our continuous integration. Every commit to GitHub or to Rust is extensively tested, and we build and upload release artifacts for every single commit that hits master. And this is quite a complex process, but it enables really interesting downstream activities, such as performance and regression testing on a commit level for all the Rust releases. We also have Crater, which is a tool that allows contributors and maintainers to run experiments on the crates ecosystem. And this is super useful to test the impact of new features to the language on the broader ecosystem. We also develop and maintain a bunch of different bots and like small GitHub apps, these kind of things, that help maintainers triage issues, merge commits, and do other housekeeping tasks on GitHub. And notable mentions here are Bors and TriageBot. And finally, I want to highlight like our cloud compute program. We, as the infra team, manage a set of servers in the cloud that allow maintainers to use pretty kind of big machines with many cores and a lot of memories to work on the compiler and on other tasks that really benefit from a lot of compute power. And this is part of the Rust Foundation's cloud compute program. And it's been, exactly, massive shout out. It's been extremely helpful for folks who don't have access to like M1 laptops or whatever big hardware in their basement to work on especially like the Rust test suite. And anecdotally, we've heard from people that making changes has like the time it takes them to run the test has decreased from like hours to 15 minutes. So it's making a massive difference and something that we as a team are extremely proud of supporting. On the user side, it's a little bit simpler, and there the most important piece of infrastructure are probably the Rust releases. There's a lot of tooling that we have that goes into preparing, publishing, and then distributing the Rust releases so that users can actually download them and start using Rust. And the infra team supports the teams of Crates.io and Docs.rs in hosting their applications. We are not involved in the development. That is something that is done by the teams, and they deserve all the credit for this. But the infra team helps with the underlying infrastructure. And there's a lot more that we do, but I think for the purpose of this talk, those are the things that are important to kind of remember. What I want to stress here is that there is a huge breadth of different pieces. We have GitHub apps, we have applications, we have a lot of cloud infrastructure, we run servers. It's a very, very broad field that the team needs to manage. And every kind of step of the development and use of Rust in some way or another touches on infrastructure that the project operates. Which kind of answers my next question in a way, because why should you care about this? Because you're using our infrastructure in one way or another. Whether you're a maintainer, a contributor, or a user of the language, you rely on our infrastructure to achieve your goals. And developing or using Rust would be more difficult or sometimes nearly impossible without some of the pieces that the infrastructure team manages. And you've seen there is a lot of infrastructure to it. And if we want contributors and users to continue to have a good developer experience, there are quite a few challenges ahead of us that we must overcome. And those come from kind of the growth of Rust that we're seeing. And the reason for this is that Rust is growing fast, and it's growing kind of really fast. We know this anecdotally through the yearly service that gets published and kind of the continuous increase in our forums, Zulip, Discord, and on social media. But we can also see this in our own metrics. And the challenge with this very fast rate of growth is that we need to be able to grow with it. Both our infrastructure and the team that manages it, we must adapt to the new demands that get created by this ever-growing community. And I want to talk about a very concrete example that illustrates this point quite nicely, and that is the metrics for our traffic. And in particular, I want to talk about the Rust releases here. This slide shows how the volume of traffic for the Rust releases has grown over the last few years, and where we expect it to be roughly next year. Whenever a user installs Rust, they download an artifact from our backends. And this traffic has grown from kind of a few hundred terabytes per month last year to over a petabyte per month this year. And this continues a trend that we've been seeing for a while, where our traffic doubles roughly every year. The scary part here are not so much the actual numbers, but this trend. Because the problem for us is that outbound traffic is not free. And while we can cover the current costs, thanks to generous sponsorships by our cloud providers, exponential growth quickly becomes unsustainable if it continues like this. And we're exploring kind of short, mid, and long-term projects to address this. And I want to briefly talk about them next. In the short term, the solution that we're working towards is, or we're working on our CDNs, content delivery networks. And without a CDN, we have this situation here where the happy users on the right, they try to install Rust, and they access our backend through the internet. Every single download of a Rust release or crate goes through our own systems, and we need to pay for this outgoing traffic for every user, even though they might all fetch the same release or the same crate. With a content delivery network, we can improve this drastically. Content delivery networks are globally distributed networks of servers that cache content and make it locally available to users. When a user downloads a Rust release, for example, they will download it through the geographically closest node. And if the release is already cached in that network, it will not be fetched from our own backend, which is both faster for the users and cheaper for us. The Rust project has hosted a lot of its infrastructure on AWS since the early days. And this is where we store both the Rust releases and crates. And we've also used AWS's content delivery network called CloudFront since the early beginning. Last year, Fastly started sponsoring the project as well, and we started using its CDN, first for the crates, and then later for the releases. And over the past few months, we have moved more and more of our traffic over to Fastly. And we're now running a 50-50 split between those two CDNs. And what this means is that we were able to distribute the costs of our traffic across multiple providers. And this is good news for us in two different ways. First, it lowers the contribution that any single company would need to make to serve or support our infrastructure. And it shows a way forward for us how we can manage kind of this growth by distributing our costs and our infrastructure across multiple providers. And this is something that we've done for a while, actually. We've been using many different partners to host our infrastructure, and these are some of them. that support both the Rust project and the Rust Foundation. And without their support, we wouldn't be able to offer all of the different services and tools that we currently have. But I want to kind of go back to this slide. Distributing the traffic is nice and it helps, but it doesn't actually change anything about the underlying trend that we're seeing. And if our traffic doubles every year, moving half of it to a different provider just means that we bought ourselves 12 months before we are back where we started. So we need to look at structural solutions to our problem. And for that, we need to understand more about our traffic and where it's coming from. And that question has a very kind of interesting, and for us at least, in the moment, a little bit unexpected answer. Because what we can see is that 50% of our traffic comes from continuous integration systems. It's not users installing Rust, it's automated tests setting up their environment. Which kind of makes sense. Just looking at kind of my own preference, it's of course to have a clean build state. So it's a fresh Ubuntu image, I install Rust in it. And I'm sure most of us do it the same way. And this may sound bad, but it actually presents an opportunity for optimization for us. Because we only have a few sources of traffic to deal with, we don't need to optimize for millions of users all over the world. And this gives us a little bit more flexibility and a little bit more tools to address this problem. And we have two different things that we are working towards. One is more in like the midterm and one in the long term. I'm using GitHub Actions here as an example, since most of us, it's the most popular continuous integration platform right now, I think, especially for like the open source community. But the principle applies in theory to all like major cloud platforms. The current status that when a user installs or updates Rust in their GitHub Actions workflow, the virtual machine running that job will fetch the release from our CDN. And this happens thousands of times per hour, and for every release and every crate that is installed in CI. But because we are only dealing with a few sources, we can optimize our infrastructure for it. Instead of serving requests for GitHub Actions from the internet, we're evaluating options to bring a cache where the actions are actually running. If we can get the most used releases and crates close to GitHub's infrastructure, we can serve these requests from a local cache and avoid fetching the data through the internet. And because we only pay for traffic that goes over the internet, this offers a massive opportunity for us to reduce our overall costs. But this approach has a few downsides. First, we can't actually reliably detect which traffic comes from a GitHub action and which traffic comes from a user. We can make assumptions based on IP ranges, for example, and the networks that the traffic is originating from. But this is not the guaranteed way to actually pinpoint it to a GitHub Actions workflow. And second, we only avoid costs if the cache is in the same network as the virtual machine running the job. We pay for the traffic over the internet. So if we want to cache content, we need to bring it into the same data center so that it never actually hits the internet. And this means the strategy only really works if we can identify where these CI systems are running and bring our caches to them. And then even if we manage to figure that out and put the cache there, we still need to route traffic to the cache and not have it follow the default path through our CDN. And again, we can use IP ranges and DNS to make this work, but it's not a science and it's a rather crude tool. So you might ask, with all of these downsides and these challenges that we're facing here, why do we still want to do this? Is there maybe not a better solution for this problem? And I want to answer this with my favorite answer to any question that I get, which is yes and no. There is a way that might be better, but it needs more work and we're not there yet and it's not open to us. What we want to do in the long term is deploy proper mirrors for both releases and crates. And a mirror is not just a cache, but it's a full copy of our data. And we can distribute them globally, and ideally third parties like cloud providers or commonly universities will be able to host their own mirrors as well. And by this, we can offer users access to this data in the regions that they live in, which provides a better user experience in some cases, and for us, gives us more tools to manage our traffic and how we serve our data. What prevents us from doing this today is that we don't yet cryptographically sign releases and crates strongly enough so that we feel comfortable putting this into networks that we don't control ourselves. Before we can put our artifacts into data centers or hand it over to other people all over the world, we need to make sure that crates and releases can't be tampered with. And this signing effort is something that a lot of people in the project are thinking about and working on. And as an infra person, I'm really excited for this to eventually land, but it still needs a little bit more time. And until that time, we do need to work on other solutions for our problem. I want to quickly kind of summarize this. We see in our own metrics that Rust is growing really fast. And we see this mostly in our traffic from the user side. And we're addressing this in 3 different ways. We're working hard on our CDNs to make them more efficient and faster. In the midterm, we're looking at caching for GitHub Actions to move kind of this bulk of traffic that comes from CI and try to handle this in a slightly different way. And in the long run, we really, really want to work on mirrors for both releases and crates to provide a more geographic spread of our data. But even with those measures in place, exponential growth is still something that's really scary to us, and we have to constantly kind of watch this and monitor where it's heading so that we can react fast enough and don't get blindsided by this growth of Rust. Traffic is something that is really falls into like this user side of our infrastructure. And as an example, I also want to talk about something where we can see this growth of Rust on the contributor side, where we provide tools to help develop the language. And the prime example here is our continuous integration setup on GitHub. If you've ever contributed to the Rustling Rust repo or any of the related repositories around this, you've seen this bot pop up in your pull request probably. Bors is a bot that we use to start our test suite and then merge the pull requests if all checks pass successfully. And what looks quite harmless from the outside quickly becomes complex if you actually start looking at the build that's happening in the background. Because our test suite now runs around 55 jobs in parallel, testing and building Rust for all tier 1 and tier 2 target platforms. The configuration for this is like a 700-line monster that no one can understand because it's way too nested. But the interesting area for us where we see how Rust is growing is that this number of jobs that we run in parallel keeps increasing every time that Rust adds support for a new platform or a new target. And as Rust is supported on a more kind of widespread, hardware or targets, our test suite is like continuously growing with it. The other area of complexity here is that as more features get added to Rust, we also see an increase in tests that need to run and an increase in the time that it needs to actually finish this process. And right now it takes us roughly under 2 hours to run kind of this full test suite and build and test these artifacts for all the target platforms. And this is okay, but I really want to talk about a different number, and that is the amount of billable time that we incur for every pull request that we merge. And right now we're roughly under 2 days. So every time that we run Bors, GitHub is essentially charging us for 2 days of GitHub Actions. And when we started digging deeper into this a few weeks ago, we figured out that we actually almost run 400 hours of CPU time for each of these pull requests. And this is 2 weeks of time. And you might wonder, like, why is this a problem for us? And the reason is that CPU time, or compute in general, together with bandwidth, those are the 2 major drivers of our costs. Nothing has a more direct impact on our overall costs than CPU time and traffic. And while GitHub is generously sponsoring our use of GitHub Actions, we need to ensure that this sponsorship is sustainable in the long term. Simply increasing the size of our test suite every time that we want to add something is not sustainable in the long run. And there's an interesting tension here between the efficiency of our test suite and the costs that we incur. In my own project, if I want to optimize my CI costs, I make the tests faster because we get charged by the minute. So if we can reduce the overall time that our test runs, it is cheaper for us. This is not true for the Rust project. We merge pull requests sequentially, and we have a queue of pull requests that always has a pull request in it. So we're continuously building on GitHub Actions. And making our CI faster actually has the opposite effect where we increase utilization and with that our costs. So we need to look at different ways how we can manage and improve our CI. It means that we need to look at other ways to optimize besides just making our CI faster by throwing more hardware at it. And the first step has been to analyze where we actually spend most of our time. Jakob in particular has been doing amazing work to analyze the metrics that we collect to find areas for improvement. And this analysis really helps us understand where we might be able to merge jobs, share work, run them on smaller instances, or how we might want to refactor our configuration over time to create a great developer experience while still managing our costs. And if you're interested in this work, come chat with me or join us on Zulip. It's fascinating, and I love talking about it. There's another reason, though, why I bring up our continuous integration. And that is that it's a foundational part of the project's infrastructure. Without it, we would have a much harder time developing the language. And its configuration might be complex, but the underlying design and architecture is actually really, really simple. Our pipeline has only 2 steps. We run 55 builds in parallel that are isolated from each other in Docker containers. So there are no side effects between tests, essentially. And while this duplicates some work, for example, building the Rust compiler for each of those 55 jobs, it makes it very easy for us to reason about the design of our CI and the interdependencies there. And this is a great example for the tension that the team is faced with between simplicity on one side and efficiency on the other, which oftentimes comes with an increased complexity. So as we start thinking about how we want to refactor our CI, we will need to make changes to what is now a very, very simple design and move into something that is more complex. And in my kind of personal opinion, this is pretty much like the biggest challenge that the team is facing right now. We're caught between these 2 extremes. We're a small team that manages a lot of infrastructure, and so far we've really optimized a lot of things for simplicity. We use hosted services, we have very simple kind of architectures and design patterns that we deploy, and that has sometimes come at the expense of scalability or efficiency. But looking at the challenges ahead of Rust as a language, as a project, and as a community, this presents us with a challenge, and this strategy is not sustainable anymore for all parts of our infrastructure. For the infrastructure that's really driving our costs, namely, again, traffic and compute, we need to accept higher complexity in order to achieve sustainability. And this presents a real challenge for us as a team, because we as a team, we need to be sustainable as well. And before I want to dive deeper into this point, I want to quickly introduce the team itself. These are the 7 folks who together work on the infra of the Rust project. We're one of the many teams of the project, and our purpose is to manage the infrastructure of the project itself, including CI, releases, the bots, and metrics. And we're 7 people, and we're each working in kind of pretty specialized environments where each of us has like a different focus typically. If we go back to this overview of our infrastructure, you see that there's quite a lot of different things in there, from servers to cloud components to GitHub Actions to CI. And those all require different contexts, different skill set, different knowledge. And as the complexity within each of these domains grows, we need to make sure that we as a team grow with that and that we are able to handle this additional work that this complexity introduces. And this is a very difficult challenge for us. And I think it's one that's different than in other teams. The first challenge that we're facing here is that working on infrastructure, especially cloud infrastructure, can be quite impactful. And I'm not sure, I don't expect many people have seen this post-mortem, but this was essentially my first kind of public appearance as a team member of the infra team, when I accidentally broke crates.io for like 15 to 30 minutes by deploying 2 things that in hindsight shouldn't have been deployed together. And it's very scary to see how the chart of like incoming requests drops to 0 and you get people showing up in Zulip asking if something happened just as you made a change to production. And as much as I would want to say that this is the only time I broke crates.io, it's not. I also accidentally broke it for users on old versions of Windows because it wasn't compatible with the SSL ciphers that were used for Fastly. And I kind of did the same to users on old macOS versions as well, with a similar problem with OpenSSL. And as you see, it's quite easy to have a big impact that is unintended, essentially. And one can argue that we could have or should have caught these things when making the changes and testing our service and configuration. And I agree that there is more that we as a team can do here. And we have certainly learned lessons about how we deploy changes to production, especially changes that are unrelated and might have consequences that you don't foresee. But the fact remains is that it's very hard to test every permutation and like every possible combination of our infrastructure and user devices. And we simply can't test everything. And the more we try to make changes to our infrastructure safe, the longer it takes to make each change. As we increase the processes that we have to test the changes, the longer it actually takes to make the change, test it, get it merged. And as this time increases, it becomes more and more difficult for volunteers to contribute to our infrastructure. Because like I work full-time in a team, I can take the time to make a change and then properly test it and spend a day spinning up old VMs with like an old Windows version to make this test whether or not everything still works. But for most people on the team, having long uninterrupted hours of time is a luxury that they just don't have. And there's a tension for us where we need to find a way how we can still encourage and enable contributions from the community without making the process so complicated that it's essentially infeasible to them. And the other challenge that we're having is that it's quite difficult to give people access. We struggle a lot with trust and privileges in the infrastructure team. Since the work on our cloud infrastructure is so impactful, and since it can do a lot of damage, as demonstrated by me, we need to be extremely conservative with the access that we give to this infrastructure, which, what we call the keys to the kingdom. But this makes it even harder for folks to contribute, because for most contributors, they won't even be able to test their own changes because they won't have access to the infrastructure. And that means that the people who have access now have even more work because they not only have their own things that they want to contribute, but they also now need to test and then report back to changes that other people are doing. And this makes it very difficult to iterate and for people to contribute to our infrastructure. There's some projects that we're working on to make this easier. For example, like giving teams like DocsRS and Crates.io access to their staging environment so that they can fully work on their infrastructure in isolation in a safe way, and then we're only involved once we want to bring this to production. But this is a very labor-intensive project that honestly we just don't have the time right now that it would require or need to actually get it done. And between this challenge of like rising complexity to keep up with the growth of Rust, the difficulty to onboard people in the team, and how strict we must be with granting access, it's really difficult for us to grow the team in a sustainable way. Besides the technical challenges that we're facing here, this is really an organizational challenge that we must learn to overcome, and we must learn how we can address this problem for us if we want a team to kind of be sustainable and avoid people burning out. After all of this like slightly depressing talk about the challenges ahead of us and the challenges that the team faces, I do want to end on like a positive note here. It's been awesome to see the growth of Rust and the adoption within the community. And I'm extremely proud of the work that not just the infrastructure team, but so many contributors and the community at large have been doing to set us up for success here. With the growth of Rust come challenges for us that we need to address. We need to find ways to manage the growth in traffic, because it is the major driver of our costs and it grows exponentially. We need to take this seriously and work on solutions that set us or that provide kind of a sustainable growth in the future. Luckily, we do have good ideas that I'm really excited about working on, but this is something that will be a topic for us that will continuously come up as the language grows and as Rust gets more adoption. Second, we need to strike a really good balance between a good developer experience on one side and a fast CI to enable this, and being smart about the resources that we have and that we get from companies like GitHub. And third, we need to grow the team as we grow our infrastructure and its complexities to prevent people from burning out and to ensure that both the infrastructure and the team are actually able to support the language and the project in the long term. Over the past year that I've been now working in the infrastructure team full time, I've again and again been amazed by the willingness of folks to put time and effort into our infrastructure. Whenever there was a fire, people rallied and helped us resolve the problem. And I want to give a massive shout out to everyone who's in the T-Infra stream on Zulip and thank them for their help and dedication over the forever, essentially, but especially the 12 months that I've been witnessing it. It's been awesome to work with everyone. Because of that, I am actually very optimistic that we will overcome all of this and that it won't be a big problem for us in the future. And if any of this was interesting to you, or you have questions or ideas, or just want to come talk to me, find me at the conference, find me on Zulip. I'd love to chat about this. And yeah, with that, I really want to thank everyone for your time and attention, and enjoy RustConf.